So let's start chapter 8, Introduction to Trigonometry. So, I hope everyone knows what is right angle triangle and the property of a right angle triangle, right? So, at least you know what is hypotenuse. At least you know what is hypotenuse. Hypotenuse is the longest side and which is always opposite to 90 degree. Wherever the 90 degrees, the opposite is called hypotenuse. So, this is the hypotenuse, and then perpendicular and base I'm going to be explaining to you in details in the later on, but for the timing just know that this is the hypotenuse, and then the other two sides is divided into perpendicular and base. Okay. Now, what is trigonometry? So trigonometry is, simply put in the simplest words, it's the ratio of sides of a right angle triangle. So in a right angle triangle, the ratio of the three sides, like itu tidaklah, or these two, whatever it is, the ratio of however we put it is called trigonometry. Okay. For example, sine theta is the ratio between the perpendicular and base. I'll tell you what is theta also. Just hold on, like listen first. Okay. So sine is the ratio between the perpendicular and base, which is not the hypotenuse triangle, the other two sides ratio. Cos is the ratio between the base and the perpendicular. Sine theta is the ratio between the perpendicular and the hypotenuse. Okay, and then cos theta is the ratio between the base and the hypotenuse. Tan theta is the ratio between the perpendicular and the base. So these three are the main three. Okay, so sine is the ratio between this and this, cos is the ratio between this and this, and then tan is the ratio between this and this. That's the main three stuff for the timing. And to remember these three formulas, you just have to memorize this wording. Some people have curly brown hair turned permanently black. If you don't want to memorize it like this, and if you think you can memorize it, sine is perpendicular by hypotenuse, cos is base by hypotenuse, tan is perpendicular by base, you can do so. It doesn't even matter how you memorize, it's your own wish. Okay. But in case you're finding it difficult to memorize this, or you're getting mixed up, then this is a very easy way to memorize it. Some people have, because some is sine, people is perpendicular, have is hypotenuse, curly is cos, brown is base, here is hypotenuse again, turned, tan, permanently is perpendicular, and black is base, the first letter of the words. Okay, so that's what it is. Now let me explain what is theta, and let me in depth explain what is perpendicular and what is base. Okay. So theta is, other than the 90 degree, we're counting the angle of either this or this. Okay. So like for example, right now I drew this triangle, but I can also draw the same right angle triangle where this is the hypotenuse. Okay. But instead of the theta being down here, I can put it up here. Okay. Now, theta is just an angle. It can be any degrees. It can be 15 degree, 30 degree, 60 degree, 90 degree, whatever theta. Theta is just an angle. Okay. The angle of this is called theta. So the angle of this can also be called theta if you want. Or you can give it another name, pi, phi, whatever, omega, whatever it is. But usually we use theta and omega or pi, phi like that, Greek alphabets, because the normal alphabets, we use it to name the triangles. Got it? Normal English alphabets, we use it to name the triangle. So it's better to use some other alphabets to name the angles, because the English alphabets will give us measurements, length measurements, and then the other like language alphabets will give us the angle measurements. So those are very different measurements. So that's why we usually use other language. Okay. So in case this is the theta, then wherever the theta is, that becomes the base, and opposite of the theta becomes perpendicular. Let me repeat that again properly. Wherever theta is, okay, that becomes the base, and the opposite to the theta becomes the perpendicular. Opposite to theta becomes perpendicular. So in case the theta is up here, even though this is ABC only, even if the same is the same triangle ABC, and this also is ABC, if the theta is up here, opposite to theta will be our perpendicular, and then where the theta is lying is our base. So that's the main distinction of theta and base. Okay, So base is usually the ground level now. So like if the theta is up here, just see it in this way, so that this is base and this is perpendicular. Got it? So it's like wherever the theta is, that becomes the base, and then the opposite of the theta is the perpendicular. Don't forget it. Now that you learn that, now cosec theta is the reciprocal of sine theta. So sine theta is here, which is perpendicular by hypotenuse. So reciprocal of perpendicular by hypotenuse ki ho jao, hypotenuse by perpendicular jao na. So hypotenuse by perpendicular. So once you memorize this and you memorize this formula, then you don't have to memorize this, because you already know that cosec will be reciprocal of sine theta, and sec theta is the reciprocal of cos theta, cot theta is the reciprocal of tan theta. See, I already told you the relationship between the sides, right? So there is perpendicular base hypotenuse, so you could do perpendicular by hypo once, base by hypo once, perpendicular by base once. I've used up perpendicular ph, bh, pb. What else can I do? We can't actually do anything except reverse it around, right? So even we're talking about ratios, right? So when you divide these two and when you divide these two, the ratios will obviously different. If this is 3 by 2, this ratio will be 2 by 3, so it's different, right? Different ratios, so we have to give separate names for those. So this is just the reciprocals of this, and we gave them separate names. So sine theta reciprocal is cosec, and it works the other way around. Also, for example, sine theta can also be written as 1 by cosec. It doesn't matter, it's the same thing. Okay, so these are the formulas. And then sometimes they might ask in exams, like not in the full form thingy, but they will use the full form of these things, because these are abbreviations. This is called sine, and most students say this is sin because it's sin, but then the full form is sine, so we call it sine. Okay, so like, and this is tangent, so but a lot of students call this as tan because it's tan or tan. Okay, so it's like short form of tangent only, so tan theta. Got it? So the full forms, sometimes they use it in multiple choices, like what is the cosecant of something, and then students are like, cosecant ki hai, cosecant ki hai. So cosecant is literally the short form of cosec. So that way, at least you'll know the full forms. So this is full form of sec, this full form of cot, this full form of tan, this full form of cos, and this full form of sine. So you just have to memorize the full forms, and then memorize this particular set of formulas, which is this easily memorizable. And then this you have to memorize the reciprocal of what is what. Okay, so once you're done with that, we can easily start with our exercises. It's quite easy. You don't have to be so worried about, well, archery go harder, nothing complicated. Anyway, before we start, let's talk about Pythagoras theorem once. Okay, Pythagoras theorem, you already know it has to do something with this thing, right angle triangle, right? So in a right angle triangle, if this is a hypotenuse, which is AC in this case, then hypotenuse square, which is AC square, say AC square, will be equal to the rest of the side square, so AB square plus BC square. I hope you know this formula. This is like basic level maths, which you have been studying from grade 7, I guess. So in this case, it will just be h square equal to p square plus b square. And then a lot of students I've seen getting confused h as height. It's not height, okay, it's hypotenuse. Okay, and the Pythagoras theorem also, I've seen a lot of students, even though they already know what it is, if instead of AC, if AB is not given and AC is given and BC is given, they tend to write AB first this side, the unknown part. But it's not like that. Whether AC is given or not given, or with what is given or what is not given, no matter what, you have to write AC on one side, the longest side, not AC, but whatever the measurement is. Sometimes it can be BAC also, right? So it can be AB also, doesn't matter. But hypotenuse should be on one side and the rest of the two sides should be on the other side. Got it? So let's try it out. 8.1. Let's read the question. Don't worry, you'll understand easily. In triangle ABC, right angled at B. So in triangle ABC, so we have a triangle ABC, and I drew the B at right angle because they're saying right angle at B, right? AB is given 24 centimeter. AB, this is AB, so this is 24 centimeter, and then BC, the down part, is called is given 7 centimeter. So I've already told you sine, cos, whatever it is the ratio of the three sides. So we need three sides, right? So we don't have the three sides. So first let's find out the third side using Pythagoras theorem. That's where we Pythagoras comes in, right? So using Pythagoras theorem, we could say AC square equal to AB square plus BC square. AC square we don't know, so I'm just going to keep it as it is, 24 square plus 7 square. 24 square is 576 plus 49, which will give us 625. AC square. Square moves this side, it becomes root over, so AC is 25. So we're getting this as 25. Now, our first job is to find sine A. So, this is a tricky part, see. We know that sine is some people have perpendicular by hypotenuse. But where is A? You have to figure that out first. A is here, right? A is, let me draw the diagram twice, okay? And I'm not going to be replacing ABC. I'm going to write A is A only, B is B only, C is C only. Same exact diagram I'm drawing, okay? Same exact diagram. So, first look at this diagram, the up one, okay? Sine A. We're talking about this A. So, theta is here, which means when they're saying A, it literally means that theta is at A. So, if theta is here, the perpendicular is what? I told you, whatever the angle is, opposite to that is the perpendicular, which means in this case is 7, and then the other one is the base. But then the formula is perpendicular by hypotenuse. Hypotenuse is the longest side, which is opposite to 90 degree, which is 25. And that's it. That's sine A. The ratio between the perpendicular and the hypotenuse. If you can cut, you should cut, but if you can't cut, just leave it as it is. Now they're asking us to find cos A as well. So cos A, curly brown hair. So base in this case is this, and the hypotenuse is 25. So done, right? So perpendicular is this, so base will be this because this hypotenuse. So base by hypotenuse, done. So let's do Roman number 2 also, sine C. And the reason I drew two triangles is that because I just wanted to mark this theta in this case. So we're talking about C. So since they're saying sine C, it means that the theta is at angle C. So right now the opposite side to theta is this, which means this becomes the perpendicular, and then this is joining the C, so this becomes the base. So sine C is perpendicular by hypotenuse. Same formula some people have. Perpendicular in this case is 24, hypotenuse is 25. Cos C, curly brown hair, base in this case is 7, hypotenuse is 25. So that's it. It's a very simple question. It's easier than you think it is, okay? You don't have to be so scared. It's just that it's a new concept that you're learning in class 10, so people usually get scared a lot. Question number 2. Let's try this. So we have two sides. We need the third side. So let's use Pythagoras theorem and then find the third side. See, the longest side, 90 degrees here. So longer side is obviously 13. So PR square equal to PQ square plus QR square. So PR in this case is 13. PQ in this case is 12. And QR we don't know, just leave it as it is. 13 square is 169, 12 square is 144, but it moves this side, it will become negative, so 144 equal to QR square. So 169 minus 144 is 25, right? Equal to QR. This square goes this side, it becomes root, so QR equal to 5. By the way, in case you're wondering why I'm not putting plus minus, we're finding the measurements of a triangle, which is the length of something. It can never be negative, so I'm always ignoring the negative part, okay? Otherwise, you know that root over 25 is plus minus 5, right? So QR, we're getting 5. So we have to find what? First, we have to find 10p. So let's find 10p. 10p. So some people have curly brown hair turned permanently black, perpendicular by base. Perpendicular in case of P. So P is here, right? P is here. So perpendicular in this case is opposite to P is this. I hope I don't have to draw two diagrams right now. So I'm just saying if it's P, then opposite to this angle is this side. So this is the perpendicular, which is 5. And then the side attached to the P is 12. So base is 12. And then we've got chord R. Chord R. So chord is the reciprocal of 10 R. So what is 10? P by B. So reciprocal of P by B is base by perpendicular. Got it? You don't have to write the formulas twice also. You don't even have to write base by perpendicular. You can literally write it directly, okay? But since we're starting out, I'm just writing step by step. Later on, we'll do shortcuts, okay? So chord R. Now we're talking about this R. So opposite to that is the perpendicular, which is 12. So perpendicular is 12, right? P don't need as well. And the base is the number attached to that, which is 5. So we're supposed to find, therefore, tan P minus chord R. Tan P we got 5 by 12. Chord R also we got 5 by 12. So if we subtract these two, we're getting 0, which is our final answer. Got it? So that's question number 2. Let's try question number 3. Question number 3 is sine A equal to 3 by 4. Calculate cos A and tan A. So let's try this. Let's draw a right angle triangle first. And remember, this is sine A. It could be either this angle or this angle, but excuse me, it cannot be 90, right? So sine, we can literally keep the A anywhere. So let's just keep it here. So we can name this B, you can name this C, or you can name it A, P, Q also. It doesn't matter what the name is, but A should be either here or here. It doesn't matter, okay? But it can't be here. So since I drew A here, see, sine given is sine A equal to 3 by 4, but sine formula is what some people have, perpendicular by hypotenuse. Since I'm taking A here, okay, the side opposite to A is the perpendicular. So in this case, perpendicular is 3, and hypotenuse, obviously hypotenuse is always going to be the longer side, which is 4. So by using Pythagoras theorem, we can find AC square plus AC square equal to BC square plus AB square. We can find AB square, right? AC square is 4. So 4 square equal to 3 square plus AB square. So 4 4 16 minus 3 to 9 equal to AB square. So AB square 7. Yeah. And square is any this side, it'll become root over. So root 7 AB equal to root 7. So we're asked to find, let's just write this root 7. We're asked to find cos A and tan A. So cos A equal to curly brown here. Since it's A, nothing has changed. So base is root 7. Hypotenuse is 4. And then tan A. 16. Okay, I hope I'm right. If I'm wrong, let me know, okay? Do check the answer on the back end. Tan A is turned permanently black. Perpendicular in this case is 3. Black base is root 7. So that's it. That's number 3. Let's do number 4. I'll do this number 4, and then number 5 you're going to try it on your own, okay? So 15, I'm going to send it. See, this is like 15 into chord A only, okay? It's the same thing. So if I send 15 that side, it becomes 15, 8 by 15. But you know that chord is a reciprocal of 10. And 10 is, see, reciprocal of 10. And 10 is what? Perpendicular by base. So reciprocal of perpendicular base is base by perpendicular. I hope you understood that. So if you draw a triangle again, mark it as A, B, C, and according to A, so this is the perpendicular, which is, in this case, the perpendicular is 15, the base is 8, okay? So perpendicular is 15, the base is 8. So by Pythagoras theorem, we could say AC square equal to AB square plus BC square. AC square we don't know. AB is in this case 8, 15 root over 64 plus 225, 9, 8, 2. I think it's 17 square, right? 15, yeah, 17 square is equal to, wait, even I'm not sure now. 7, 7, 4, 9, 9, 4, 7, 7, 8, 9, 10, 11. 17, 9, 8, yeah, 17 square. So this is 17. Okay, so we're getting 17. We have to find sine A. Some people have, so perpendicular is 15, hypotenuse is 17. And then we have to find sec A. Sec A was opposite of what? Cos A, right? And cos is curly brown here, reciprocal of that. So here is first, so hypotenuse first, and then base is 8. So that's it. That's question number 4. Now try question number 5. It's exactly the same, and when they say like find all the trigonometric ratios, literally they mean to say they're asking you to find sine theta, cos theta, tan theta, cosec, sec, okay, cot. All these you have to find applying the formula, and then you can name anything you want. You can name it A, B, C, and then just put a theta somewhere. You put this as theta, this will become the perpendicular, this will become base, this will become hypotenuse. Anyway, try it.